And welcome. This is your first of 3 videos about how to solve proportions. This is the video number 1, and then it'll be in a playlist of videos, so I'll release them all at the same time, but then you can go back and figure out, based off the problem that you need, which one to use the best. So this first way is using inner rainbows to help us solve proportions. Right down below here I have my inner rainbows. You can kind of see those. There's no ratios there, but remember we're looking top to bottom for a multiplier or a common scale factor inside of our ratios. So at this point, just listening through, click through, and I'll have you jot down some examples in your notes. Let's take a look at what we're used to compared to what's different now that we're solving proportions. What we're used to is tables where I'm giving you figures and ratios in dollars and hours or miles and gallons, stuff like that. So we're used to seeing tables that would say for 1 hour of work I would get $10, for $2 of work I would get 20, for 5 hours of work I would get 50, and for, let's say, 10 hours, I would get $100. With those kind of tables, we can see our inner rainbows between the number of hours and the number of dollars. So in this case, I see that hours have a multiplier of 10, but times 10, times 10, times 10, and because each and every one of them has that times 10 multiplier, I know that they are proportional all to each other. So I can see that relationship happening all the way through every single ratio. What's different is now I'm only going to give you 2 ratios, and in one case of one of the ratios, I'm going to leave out one of the numbers. And so if I say 1/2 is equal to 5 blanks, I just gave you the answer right there. Let's change up the numbers. 1/2 is equal to 6 blanks. Then we have to use that same idea, now knowing that they're equal, meaning that you already know they're proportional, which is why this is called solving a proportion. So I'm giving you 2 ratios that we know are equal, except I'm taking one of the numbers away and asking you to solve for it. So now we can see here that we can see a multiplier, we can see a constant scale factor of times 2. And so I can tell on my second ratio that's equal or proportional that I can multiply 6 by 2 to end up at 12. And we knew this one was kind of a good example, but this was what's different when we're solving for proportions. This is just a general reminder to remember that proportions are equal fractions. So just as a reminder on this one, please remember that whenever we see something equal to, we know they're proportional. So if you kind of have see a ratio and then one number missing, you know that's a proportion, but since you know they're equal, you know they're proportional, you can use any of these methods. So here's a couple examples. These are the ones that I'd like you to write down in your notes. And so from here, I'm just going to put up that write down tool. And from here, I'd like you to jot these down into your notes so you can see some different examples using inner rainbows. At the top of your notes, please title these inner rainbows so you can see the different examples of what to look for and what to do. But in this case, I'm just going to have you start with these notes. Gigantic pencil there, we'll toss that up in the top corner. So if I'm using inner rainbows for this first one, 4/12 is equal to 11 blanks. What I want to see in your notes is this kind of arrow and a multiplier of 3 between 4 and 12. And then I'd like to see that on the opposite side so you can see the connection of rainbows. Everybody's doing this really, really well. You showed me that on that mini quiz, but now we can see how we can use it to solve proportions rather than in a table. Also in your notes, please set up 9/99 is equal to blank 44ths, so we can see that we can do some reversals. Since I don't know this numerator, I'm really not going to be looking for a multiplier between 9 and 99, because I'm going to be looking for a divisor, because I want to start here at 44, divide by something to end at something. So when I look at 9 divided by 90, something equals 99, I know that I can divide by 11 to equal 9. And so I'm going to do that same thing on the opposite side, where I take 44 divided by 11, and I'm going to end up with my numerator using the inner rainbows to solve proportions. And that's going to give me an answer of 4, because 44 divided by 11 equals 4. So jot down those examples in your notes so that you can see how to solve. Last thing, and this is with all methods and all the ones you'll see, all these methods will work even if there's no whole number. Sometimes it just gets a little tricky and messy. So we know for sure when we see this that there is no multiplier that 3 times something equals 7. That's not going to be a whole number, at least we know. So what we can do always here, though, is we know about our fact families. We know that 3 times something equals 7. We just know that something isn't a whole number. Using those fact family ideas, I should be able to take 7 divided by 3 to find that something. So if I take my denominator and divide by my numerator, I'm going to find out that something. Then with that same idea, knowing that these are proportional, I can take that 22, because 22 times something is equal to blank, when we don't know that's something yet. But I also know that because they're equal, 3 times that same unknown number is equal to 7. So now if I take 22 times our unknown number from before, from this number right over here, I will get to my final answer. And in this case, when I take 7 and divide it by 3, I end up with 2.3 repeating. And so now if I take 22 times 2.3 repeating, I'm going to get my final answer, which when I punch it through comes out to 51.3 repeating. So I can still do these problems even if I don't have a whole number, but it does just get a little messy. So that is first method. Tune into the other videos to see the next two methods and to figure out how we can keep continuing to solve proportions.